Good morning, champs. Today, we learn the general method for mapping 3 points with a Möbius transformation. We want a function that sends z1 to w1, z2 to w2, and z3 to w3. The key fact is this. A Möbius transformation is determined by 3 points. But instead of trying to guess the formula directly, we use a standard trick. We normalize both sides. First, we normalize the input points. We want z1 to become 0. To make something 0, we put z minus z1 in the numerator. Next, we want z3 to become infinity. A fraction becomes infinite when the denominator becomes 0. So we put z minus z3 in the denominator. Now we have z minus z1 divided by z minus z3. This sends z1 to 0 and z3 to infinity. But we also want z2 to become 1. When we plug in z2, we get z2 minus z1 divided by z2 minus z3. This is not necessarily 1, so we multiply by the reciprocal. That gives us the normalized expression, z minus z1 divided by z minus z3 times z2 minus z3 divided by z2 minus z1. Now, z1 goes to 0, z2 goes to 1, and z3 goes to infinity. Then, we do the same thing for the target points. We build an expression in W that sends W1 to 0, W2 to 1, and W3 to infinity. That expression is W minus W1 divided by W minus W3 times W2 minus W3 divided by W2 minus W1. Now comes the key idea. If z maps to W correctly, then the normalized z value must equal the normalized W value. So we set those two expressions equal. This gives the general 3-point Möbius transformation formula. The important point is that we do not memorize a giant fraction. We build it step by step. Send the first point to 0, send the third point to infinity, rescale so the second point goes to 1, then do the same thing for the target points. That is the whole method.